Okay, so this video is about making disorders of sexual dysgenesis simpler to understand. Now, first of all, let us follow these principles that will be used against all the questions. So, the first point goes like this: in male, Sertoli cells, what's wrong? Sertoli cells produce Mullerian inhibiting factor that induces Mullerian agenesis. Wolffian duct give rise to testis and vas deferens. Leydig cells produce testosterone, which give rise to internal genitalia, and dihydrotestosterone, which give rise to external genitalia. And we also know testosterone, with the help of 5-alpha reductase, gets converted into dihydrotestosterone, and with the help of aromatase, give rise to estrogen. Now, the second point is in female, Wolffian duct degenerates with the absence of testosterone, and the luteinizing hormone acts on theca cells to convert cholesterol to androgen, whereas aromatase helps to make the androgen to estrogen in the granulosa cell, which is stimulated by FSH. Now, the third point says in male, LH acts on Leydig cell to produce testosterone, whereas FSH acts on Sertoli cells to produce Mullerian inhibiting factor. And finally, we should understand the principle karyotype versus phenotype. So now let's solve few of the questions and use these principles to try to solve them. So the first case goes like this. So we have a phenotype male with a normal genitalia. Genotype is also normal. So the male genotype has a male phenotype. Now in the imaging, there is rudimentary uterus in addition to male internal genitalia. So seems like the degeneration of the uterus was left out. It didn't happen. So based on our principles, with the help of Mullerian inhibiting factor, it induced Mullerian agenesis. So it seems like it should be due to the deficiency of Sertoli cells or Mullerian inhibiting factor. So let's take our answer. So answer is absent Mullerian inhibiting factor or Sertoli defect. Now the second question goes like this. So we have a phenotype of female, but the genitalia looks ambiguous. Genotype is of male. So we know the problem is related to the external genitalia. So it is appearing like a female genitalia because, as we know, external genitalia in male is given by dihydrotestosterone. Also, the physical exam shows bilateral masses in labia, so it shows failure of descent. Now, in lab studies, there is decreased conversion to dihydrotestosterone. So, from the principle, we know it is either 5-alpha reductase deficiency. So 5-alpha reductase deficiency sounds about right. So now let's check the answer. Okay, so the answer is 5-alpha reductase deficiency. Now let's go to the third question. So we have a female genitalia in the phenotype, but it is genotypically male, and the imaging shows rudimentary vagina but an absent uterus. Physical exam shows normal breast development with absent pubic hair diagnosis. So again, using the principles from above, we have an absent uterus in this case. So it means the Mullerian inhibiting factor has worked. Uh, External genitalia and as well as internal genitalia are absent. So both of these act on a common receptor, which is the androgen receptor. So defect of this receptor can result in absence of both external as well as internal genitalia. So all the testosterone gets shunted to form estrogen in the presence of aromatase, because the testosterone is building up as well as the dihydrotestosterone, which aren't working, which aren't doing its job. So testosterone give rise to a lot of estrogen. That explains the absent pubic hair and the breast development. So the defect is androgen insensitivity syndrome due to the defect in the androgen receptor. Now let's discuss the next question. We have a female, phenotypically female with normal genitalia. Genotype also checks out. It's a female, but the imaging shows rudimentary vagina with an absent uterus. So the uterus is not formed in this case, and as we know, the uterus is formed by the Mullerian duct. So in this case, the Mullerian duct has undergone agnesis on its own. There is normal breast development, normal pubic hair growth. So the defect is in the Mullerian duct agnesis. Let's take the answer of number 4. So answer is Mullerian agnesis. Now let's do another question. So we have a genotypically female, and the female has a normal internal genitalia, but there is virilization of the external genitalia. So it is a female, it has an internal genitalia, but somehow externally it looks like a male. So this happens due to clitoromegaly, where the clitoris looks like a phallus, and also there is maternal virilization. So this is a hint of excess androgen. So here excess androgen happens when this reaction from testosterone to estrogen is affected, which is regulated by aromatase enzyme. So defect in this enzyme can result in clitoromegaly as well as maternal virilization. Now let's do another question. Absent olfactory bulb with loss of smell with central hypogonadism. So this is very easy. This is Kallmann syndrome. Now let's do another question. We have a genotypical male, but there is presence of female internal genitalia. That is, it has intact uterus, fallopian tube, upper vagina, and also externally it looks like an external genitalia. So from this we can see that Mullerian inhibiting factor is not formed, so looks like a Sertoli defect, because this will help to disappear the female internal genitalia, and the external genitalia is also uh, not present. So somehow looks like there is also defect in the testosterone production by the Leydig cell. So this is a case of Swyer syndrome, which is the defect in Sertoli as well as Leydig cell. So Sertoli defect as well as Leydig defect is seen. Let's do another question. So we have a genotypical male, but there is no any female or male internal genitalia, but uh, the external genitalia looks like a female because no any genitalia has developed. Also, there is no breast development, no axillary or pubic hair development. So from this, we can deduce there is no estrogen. Also, from the absence of the male or female internal genitalia, we can deduce uh, that the internal genitalia has not developed. So from the principles above, let us study again. So we know to produce testosterone, one needs Leydig cell, and to produce Mullerian inhibiting factor, one needs Sertoli cells. So since MIF has done its job because the internal genitalia, the female internal genitalia is absent in this case. So Sertoli cells are okay, but due to absence of external genitalia and also absence of estrogen, we can see it is a testosterone deficiency. So testosterone deficiency occurs. So testosterone deficiency occurs either due to Leydig cell defect or due to the absence of the LH receptor. So answer in this case is LH receptor defect or Leydig cell atrophy. Now let's move on to our final question. So we have a genotypical female, but there is absence of female internal genitalia, whereas the external genitalia has been developed. So in such case, it is often due to Mullerian duct agenesis. So Mullerian duct helps to form the internal genitalia, and since it's a female, there is no any kind of male business going on like production of MIF or something like that. So it happens due to regression of the Mullerian duct. So Mullerian atrophy would be the best answer. So the answer is Mullerian agenesis. So these are all about the common disorders of sexual dysgenesis. Thank you for watching.